Hi, this is the second lesson in circular motion. In this lesson, I'm going to discuss exam style questions. Before watching this lesson, it's better to go through my first lesson. The link or the URL for the first lesson is given in the description of this video. Okay, before starting the questions, I would like to revise the equations related to circular motions quickly. The first equation, you should know the equation for the centripetal acceleration. I derived that equation in my first lesson. You can go through it. Okay, the centripetal acceleration is given by A equal V squared over R, where V is the speed and R is the radius. You can use this equation at an instant. At any instant, you can use it. Even when the speed varies, for example, in vertical circular motion, you can use it at an instant. Okay, the second equation. So this centripetal acceleration always acts towards the center of the circular path. So according to Newton's second law, there will be a resultant force towards the center of the circular path, that is called centripetal force. F equal ma. So A equal V squared over R. So F equal m V squared over R. This is the equation for centripetal force. An object which is in circular motion might have more than one forces acting on it. So we need to resolve all the forces towards the center of the circular path. That will be the centripetal force, that is equal to mv squared over r. Okay, the third equation you should know about the time period. The time taken to complete one full circular path is called time period of the circular motion, and the number of orbits completed per second is called frequency of the circular motion, and those two f and t are related by t equal 1 over f. So that's a well-known equation. Frequency and time period are related by this equation. Then about angular speed. Angular speed is the rate of change of central angle. So angular speed is denoted by omega. The change in central angle t during time t means omega equal theta over t. So theta is the change in central angle during the time t. The theta must be in radians. T normally should be in seconds. So the unit of omega will be radian per second. If the object completes one full orbit during time period capital T, that is the period of the time taken, so theta will be equal to 2 pi radians, so 2 pi over T. It also could be used as a standard equation, omega equal 2 pi over T. We know T equal 1 over F, so if I replace T by 1 over F, it will become omega equal 2 pi F. Okay, so you should know all these equations, omega equal theta over T, omega equal 2 pi F, or omega equal 2 pi over T. The next equation is V equal the speed at an instant. Careful, speed at an instant is related to angular speed by V equal R omega, where omega is the angular speed, R is the radius of the circular orbit, V is the velocity, I can say, or velocity or the speed at an instant. Okay, speed at an instant, radius of the orbit, angular speed at that instant. Angular speed can change, for example, during vertical circular motion. The angular speed will change. Go through my first lesson there, I explained those things. Okay, so next equation is V equal R omega. Then we can replace here V squared by R. So I can say A equal R omega squared. If I replace V squared by R squared omega squared, substitute here, you will get A equal R omega squared. Another equation for the centripetal acceleration. Again, if I use Newton's second law, centripetal force F equal mr omega squared. So these are the equations we are going to use in circular motion. Better to know or remember these equations. Normally they give you of these equations in the exam paper. Depending on the exam type, say Cambridge or Edexcel, they give different equations. But it's better when you do questions, you will remember these equations. Better to know these equations. Other than that, we will resolve the forces towards the center, and that will be the centripetal force. So only the equations used in circular motion are these are the equations. Okay, so this is the first question. A smooth sphere of mass 800 gram is attached to one end of an elastic string of length 1.2 meter. and rotated on a smooth horizontal flow about the other end of the string. When the sphere completes 30 revolutions per minute, length of the elastic string becomes 1.8 meter. You know, I already explained that in my first video. When the sphere rotates or moves on a circular path, it will have tendency of moving away from the center. That's called due to the inertia, that is a centrifugal effect. So the length of the string will increase because it's an elastic string. So the length of the string becomes 1.8 meters. So the extension is 1.8 minus 1.2, 0.6 meter is the extension. So we can use F equal K delta X. Anyway, Hooke's law we can use. That's the last part of this question of this, the fourth part is about finding the K. Okay, anyway, before that, first part, find the angular speed of the sphere. So angular speed, I wrote it already, omega equal, we can use 2 pi f or 2 pi over t. So here they are saying, the question says 30 revolutions completed during 1 minute. That is, during 60 seconds, it completes 30 revolutions. So first part, I can say during 60 seconds, it completes 30 revolutions. So 1 second, or we can say that 1 second, or the time taken for one revolution. So that is 30 revolutions happens during 60 seconds. So one revolution, the time taken for one full orbit is 2 seconds. That is going to be the time period. T is equal to 2 seconds. Okay, the time taken for one full orbit is 2 seconds. That's a time period. So the question is, find the angular speed of the sphere. So omega equal 2 pi over t. We can use that equation, that is 2 pi over 2, that will be 3.14 radian per second. That's the answer for first part. The second part, find the tension of the string. You know, it's moving on a circular path on the flow. So the second part, it's moving on a circular path. So this is the center, this is the string, the sphere is here. So this is the center of the circular path. Length of the string we know, that is the length of the string is 1.2 meter. If we consider the free body force diagram for the sphere, the forces acting on it, the weight will act downwards. There will be normal reaction from the flow. They will balance each other because there are no vertical resultant force. So the resultant force towards the center of the circular path is the tension. I already explained that in one lesson 1. The sphere has tendency of moving away from the center. So it will stretch the string. So when the stretch is stretched, there will be tension. So tension provides the required centripetal force. We know the equation F equal mr omega squared. We know that F is the tension. So tension provides the required centripetal force. I can say T equal mr omega squared. Mass of the sphere is given 800 grams, convert to kilogram, 0.8. The radius of the circular orbit is 1.2. And omega, we already found it, 3.14 square. Solve it, you will get the tension, that is will be equal to 14.2 Newton. That will be the tension of the string. Okay, third part, find the speed of the sphere. So we can simply use V equal R omega. We know the R, that is 1.2. Omega, we found it in the first part, 3.14 meter per second. So when you solve, you will get 5.65 meter per second. That's the speed of the sphere. Fourth part, find the force constant K. That's by using Hooke's law, because it's an elastic string, so it's extended due to centrifugal effect. It has tendency of moving away from the center, that causes the string to extend. So we know the extension. So fourth part, we'll find the extension. Delta x is equal to, final length is 1.8, initially 1.2, 1.8 minus 1.2, that is 0.6 meters. So the tension, we already found it. We can use the equation F equal K delta X. F is the force acting on the string, which is the tension. We already found it in the second part, that is 14.2. So 14.2 is equal to K times 0.6. So find the K. That will be equal to 23.7 Newton per meter. Okay, so this is the second question. So here the diagram is given. This is small, it's a smooth horizontal table, and there is a small hole on it. Through the hole, a light inextensible string of length 1 meter is passing through the hole, and one end a small sphere P1 is attached. On the other end, identical and next sphere P2 is attached. Okay, so if you keep it like this, certainly what will happen, due to the weight of the P1, it will move down because it's a smooth surface, there is no friction. So when P1 moves, P2 will move towards the hole, but that won't happen here because P2 is moving on a circular path. Okay, so by keeping the P1 fixed at a particular depth from the hole, which is 0.5 meters, the P2 is allowed to move on a circular path. So due to centrifugal effect, or the P2 will have the tendency of moving away from the center. Due to that reason, P2 will move on a circular path without moving towards the hole. Okay, the question is like this. So I told in my first lesson, without the idea of centrifugal effect, most of the circular motions cannot be understood. So to understand the circular motion clearly, we should have the idea related to centrifugal effect. Okay, so here the P2 will not move towards the hole because of the centrifugal effect. So here the length of the string which connects the both P1 and P2 is 1 meter. This is at a depth of 0.5 meters, means the radius of the circular path of P2 is 0.5, because this is 0.5 means total length 1. So 1 minus 0.5 is the radius of the circular path of P2. Is moving on a circular path. Okay, so the first part, there are two parts. I wrote only the first part, I'll write the second part. First part, it says find the speed of the sphere P2. P2 is moving on a circular path. We need to find the speed of it. Okay, we'll think about the free body force diagram of this the second question. So second question, first part. So we'll think about the free body force diagram for P1 and P2 separately. So if I think about P1, so it has two forces acting on it. Weight is acting downwards, tension is acting upwards. Those are the two forces acting on P1, the sphere. So second sphere, P2, it has weight downwards, identical sphere, so same weight or same mass, either way we can say. And there will be normal reaction from the table. They will balance each other, and there is a force towards the hole. The string is attached, it's passing through the hole. There will be a tension, so I can say the tension this way. Anyway, I can draw it horizontal also, it's not an issue. So it's a three-dimensional diagram, looks like a slant. So I can say the tension acting on the P2 towards the center. So we know that the centripetal force for the P2, the required central force, is provided by the tension. But if I consider the first sphere P1, since it's at rest at a constant depth of 0.5 meter, T equal mg for the sphere P1, because it's at rest. So that same tension, because it's same inelastic string, light inelastic string, so the same tension will act at on the P2 also. So here the tension, which is going to be the centripetal force, is also mg. So I can write for P2, the centripetal force F equal mv squared over r. F is tension, so T is the centripetal force, T equal to mg. So mg equal mv squared over r. I hope you understood, because the same string passing through the hole, same tension will act here and here. The same string, light string, so same tension will be there. String has no weight. Light string is mentioned, light string. Okay, so since P1 is at rest, T must be equal to mg, same T. So mg is the centripetal force for the P2. So mg equal mv squared over m and m will get cancelled. So v is going to be square root of gr. You know m and get cancelled, cross multiply gr square root of it. So that's going to be square root of 9.81 into the radius of the orbit is 0.5. 0.5. So solve it, you will get the answer. That's going to be 2.21 meter per second. That's the speed of the sphere P2. Okay, so second part of the second question, I wrote it now. Find the period of motion, that is period of circular motion of the sphere P2. So we found the speed already. We can use V equal R omega, one equation, omega equal 2 pi over T. From that we can find the period. So V equal R omega and omega equal 2 pi over T. So substitute, I can say if I combine these, V equal R into 2 pi over T. So T equal 2 pi R, the circumference over V, 2 pi into, the radius is 0.5 over V, we found it 2.21. So the time period will be equal to 1.42 seconds. That's the answer for the second part, 1.42 seconds. Okay, so this is the third question. On the Earth, at the equator, a digital balance is kept, which is calibrated in newtons. That means it records or it shows the readings in newtons. A child is standing on the weighing scale. You know, Earth is spinning about its axis, right? Radius of the Earth is almost 6,400 kilometers. And the first part, find the angular speed of the child due to spin of the Earth. Okay, so the Earth is spinning. We know the time period of spin of the Earth about its axis is 24 hours. So first part, we can use omega equal 2 pi over T. Question number 3, first part. We need to use omega equal 2 pi over T. T is 24 hours, so 2 pi over 24 hours into 60 minutes into 60 seconds, radian per second. Solve it, you will get the answer 7.27, 10 to the power minus 5 radian per second. Second part, find the speed of the child due to spin of the Earth. So child is moving on a circular path due to spin of the Earth. So V equal R omega. Radius is 6,400 kilometer, convert to meter, multiply by 1000. Omega 7.27, 10 to the power minus 5. That much of meter per second. The answer will be, the speed is equal to 465.4 meter per second. So that's the speed at the equator due to spin of the Earth. There are two more parts. Actually, there are 4 parts. I wrote already 2 parts and I discussed it. I'll write the next 2 parts. Okay, so third part, find the unbalanced force acting on the child due to spin of the Earth. If you ask this question for Unit 1 child or who in IGCSE, they'll say there is no unbalanced force, because normally when you stand on the ground at rest, the resultant force acting on the person will be equal to 0. Normal reaction will balance the weight, because when we learn mechanics without circular motion, when we learn just condition for equilibrium, we say when a person stands on the ground, the resultant force acting on the person will be equal to 0. There we don't consider the spin of the Earth, but when we consider the spin of the Earth, actually there will be an unbalanced force, because the child is moving on a circular path standing at the equator of the Earth. So the child should have an unbalanced force, that is the centripetal force towards the center of the Earth, which is given by F equal mr omega squared or F equal mv squared over r. One of it you can use. So third part of the third question, I can use either F equal mr omega squared or mv squared over r. Both will give the same answer. I'll use mv squared over r. that is the centripetal force, that will be towards the center of the earth. That force will act towards the center of the earth, that will be the centripetal force. So mass of the child is given 60 kilogram. The speed already we found it, which is 465.4 all things squared over. The radius of the earth is 6,400 kilometer, convert to meter Newton. So that will be a very small value. That will be 2.03 Newton. Okay, fourth part. Find the reading of the weighing scale. Normally we say the reading of the weighing scale will, actually first you should know which force does it read. Weighing scale reads the push by the person, or third law pair of the normal reaction. Is it? If you draw the free body force diagram for the fourth part, this is the weighing scale, this is the child. If I draw this way exactly on the equator, the child will have the weight. Earth will pull the child towards the center, that is due to gravitational effect. The child will have force towards the center, that is the weight first. Then child will push the weighing scale and exert a force on it, that is the contact force, that will be read by the weighing scale. The child will push the weighing scale with a force R. Upon Newton's third law, weighing scale will push the child upward direction. I'll mark it here R. I should mark R here, but I'll mark it here. Okay, so the child has an unbalanced force towards the center, that is a centripetal force. The child has an unbalanced force towards the center, that is a centripetal force, which is 2.03 Newton. That is mg minus R is the unbalanced force. So towards the center we may consider the unbalanced force towards the center for the child is mg minus R, that is 2.03 Newton. So R I need to find it because weighing scale reads R. Is it? Weighing scale reads the push by the child. So R is equal to mg minus 2.03. So 60 into 9.81 minus 2.03. So that will be smaller than the actual weight of the child. That is going to be 586.6 Newton. So the weighing scale won't read a value equal to mg. That will be smaller than the actual weight because due to the centripetal force. Okay, so this is the fourth question on conical pendulum. So a conical pendulum consists of a bob of mass 510 grams on a string of length 60 centimeters. So we need to assume the string is light and inextensible. The bob is rotated on a horizontal circular path and the string makes an angle of 30 degrees with the vertical. So first we'll draw a diagram, rough diagram for the conical pendulum. So this is the vertical line. It's moving on a horizontal circle. So this will be the center of the circular path. This is the point P where the string is connected or attached. The length of the string is given 60 centimeter. And the string makes an angle of 30 degrees with vertical. Also, it's better to draw free body force diagram for the bob. So this is the center. So this is the radius of the circular orbit. So we can find the radius by using this right angle triangle. Yeah. So R is equal to 60 sine 30, that is 30 centimeter will be the radius. We can find that simply. We can say the radius R is equal to, in this right angle triangle, R is equal to 60 sine 30, that is going to be 30 centimeter. Okay, so we should draw a free body force diagram for the bob also. If I draw the free body force diagram, weight will act vertically downwards. The tension will act along the string, this direction. So it makes an angle 30 degrees with the vertical. So center is somewhere here, O is the center. I marked it here. Normally free body force diagram we don't mark the center, but anyway, just for convenience I mark the center also. Okay, now we'll see the first part. Calculate the tension on the string. So they are saying it's moving on a horizontal circular path, means there is no upward or downward motion of the bob. So the resultant vertical force must be equal to 0 because there is no vertically up or downward motion. So first part, the vertical, if I use, the resultant force in vertical direction must be 0 according to Newton's first law. No vertical upward downward acceleration moving on a horizontal circle. So that means T cos 30 minus mg equal to 0. So T cos 30 equal mg. So T will be equal to mass of the bob is given as 510 grams. So convert to kilogram, 0.510 into 9.81 divided by cos 30. So tension will be equal to 5.78 Newton. Okay, second part, calculate the speed of the bob. So the speed, it's moving on a circular path. I can say it's moving at a constant speed. The speed I can, if I say that is v, this is the center. I found the radius 30 centimeter means 0.3 meters. The required centripetal force for the circular motion, that is towards the center, provided by the component of the tension, which is T sine 30. T sine 30, because weight is vertically down, it has no horizontal component. So the centripetal force towards O, the center of the circular path, this is the center of the circular path, not P, not P. O is the center of the circular path. It's moving on a horizontal circle. So O is the center. So the resultant force towards the center is the centripetal force, that is given by F equal T sine 30. That's going to be mv squared over R. So we know the T 5.78 sine 30 equal m 0.510 v squared over R. We found it 30 centimeters, 0.3. Find the v, you know, cross multiply, divided by 0.510, take a square root of it. So v will be equal to that's a third, calculate the speed of the bob. Yeah, that will be equal to 1.30 meter per second. Okay, third part, find the or calculate the period of circular motion of the bob. So that's the third part. So we know that it's moving at constant speed. So every point the speed is the same. So the total circumference 2 pi r is the distance traveled during time period, capital T. So the speed v equal 2 pi r over t. Or you can say v equal r omega. Same thing, you'll get omega equal 2 pi over t. If you replace omega by 2 pi over t, you will get 2 pi r over t. So t is going to be 2 pi r over v. So that is 2 pi into radius is 0.3 over the speed we found it 1.30. So the time period will be equal to 1.45 seconds. So that is, again I'll write it here, the time period t is equal to capital T is the tension, also same notation we are using for tension, but that also time period, this is tension, don't get confused about the same notation. The time period t equal 1.45 seconds. That's the end of fourth question. Okay, so this question, fifth one, is related to merry-go-round, but that is actually the application of conical pendulum. There are 4 parts. I wrote 2. The other 2 I'll do it after completing these 2 parts. So the conical pendulum, actually the basic idea of merry-go-round. Okay, so it's moving on a horizontal circle. It's rotating about A. So the arm also rotating. That we don't need to consider. The arm AB is rotating, but we should think about the chair C and occupant as one object. So we can assume this as the bob. Oh, it's moving on a horizontal circle, but there is tension in this direction. Okay, so they are saying the radius of the circular path is this one. O is the center of the circular path. It's moving on a horizontal circle, so there is no vertical resultant force. So it completes each revolution during 6 seconds. So that means the time period is capital T, time period is 6 seconds, and the radius is 5 meters. The question is calculate the speed of the chair. That's the first part. Okay, so we know the time period, and we know the radius, so we can use V equal R omega, omega equal 2 pi over T. By using those two equations, we can find the speed. Okay, so the question number 5, first part, V equal R omega and omega equal 2 pi over T. So if I combine this, it will become 2 pi R over T. So 2 pi into radius is 5 over. The time taken T is 6 seconds. So if you solve it, you will get 5.24 meter per second. That's the first part. Second part, we don't need to draw a free body force diagram for the first two parts. Later we'll draw it for the other two parts. Okay, so the second part, calculate the unbalanced force on C. C is together, the occupant or the person and the chair together as one object. So unbalanced force, because it's moving on a circular path, unbalanced force means the centripetal force which is acting towards the center. So that is the unbalanced force. Unbalanced force means centripetal force. So F equal mv squared over r. So the mass is not given. The total weight is given as 800 newtons. The total weight. It's not the mass, so it's a weight. So we need to divide by 9.81 to get the mass. So m we can get 800 divided by 9.81, that's the mass, into V squared 5.24 squared over R. R is 5 meters. Sorry, I took the equal sign here, right? Okay, so when you solve it, that will be the centripetal force. So that will be equal to 447.8 Newton. So that is the unbalanced force or centripetal force. Both same in circular motion. Unbalanced force towards the center, yeah. So there is no unbalanced force in vertical direction because moving on a horizontal circle. So that means no vertical unbalanced force. The unbalanced force is only due towards the center O. So now we'll discuss the third and fourth parts. I'll write the question. Okay, so this is the third part. Calculate the angle of inclination of the cable with vertical. So for that, better draw a free body force diagram. So that's question number 5. Third part. For that, we need a free body force diagram. So if I draw the chair and the occupant as a bob together as one object or one particle, there will be weight vertically downwards, mg. And there will be tension along the cable. So they are asking to find this angle of inclination with vertical. So that means they are asking this angle. This is the question, theta. That means this will be here theta, alternative angles. So this is the theta, we need to find it. And we know the center is somewhere here. This is the O, center. Okay, so we know it's moving on a horizontal circular path. No vertical resultant force. So if I resolve vertically upwards, T cos theta must be equal to mg because no resultant vertical force. For resolve towards the center, the required centripetal force will be provided by the tension of the cable, or we can say the required centripetal force is provided by the horizontal component of the tension towards center O. That will be the centripetal force. So T sin theta equal mv squared over r. Second equation. Divide second equation by the first equation. T sin theta over T cos theta equal mv squared over r over mj. T and T will get cancelled. Sin over cos tan. And m will get cancelled. V squared over rj. So tan theta is going to be V squared over rj. Substitute. We found it in the first part, that is 5 point that is going to be sorry, we found the V Uh, yeah, 1 minute. We can use simply like t sine theta mv square over. We know the answer. We already found it in the second part. That is 800. I'll replace that by 800 because sorry, we found the second part. The unbalanced force towards the center. We found it 447.8. So I replace it by 447.8 Newton. We found it in the second part, that is the resultant force towards the center is the unbalanced force, that's a centripetal force. We already found it in the second part, so that will be easy. So I'll substitute this 800. I don't need to calculate again. If you want, you can calculate it, but not necessary. Already we calculated the second part, 447.8 over mg. So tan theta will be 447.8 over mg. That's given here, 800 Newton. The total weight is 800 Newton, 800. Okay, so take tan inverse tan, you will get theta is equal to, yeah, this will be 0.559, yes, 0.559. So theta will be tan inverse, so that will be 29.2 degree. If you want, you can calculate mv square r, but not necessarily. We already found it in the second part. Mv square r is the centripetal force, so I replace that by the calculated value in the second part, 447. So theta will be 29.2 degree. Okay, so last part, fourth part, calculate the tension of the cable. Now we know the theta, right? We already found it, theta. Substitute this value either in 1 or 2. Either in one of these equations, substitute theta 29.2. So here we know mg is 800. Substitute theta 29, you will get the tension T, or substitute this 29.2 in the second equation. We know the theta. We know 448, you can find the T. Wherever you want, you can substitute and find the T. That's the last part. Okay, so third part I'll substitute, fourth part I'll substitute in the equation T sine theta equal to 800 newtons. Sorry, we found it as a centripetal force, that is 447.8. So that is T sine 29.2. We found that in the third part, 29.2 equal 447.8. That's the second equation, right? So find the T, that's a tension. So that will be equal to 917.9 Newton or 918 Newton. Okay, so this is the sixth question about circular motion of an aeroplane. It's like a motion on banked track. Okay, so here they are saying the aeroplane is flying on a horizontal circle. So again, there is no resultant vertical force, something like conical pendulum. But there will be a lift. Yeah, that is due to Bernoulli's principle. Bernoulli's principle is not in the Edexcel or Cambridge syllabus, I think. Yeah, so it's not in the Edexcel syllabus. Bernoulli's principle that causes the lift. Anyway, we don't need that here. So due to Bernoulli's principle, there will be lift on the wings. But the question, it says the lift is acting always upward, perpendicular to the wing. So the lift flying upward, which acts perpendicular to the wing. So in this diagram, the lift should be this direction. So here the lift must be this direction. So I can say the lift should be perpendicular to the wing this way. Anyway, so we'll draw a free body force diagram. So upwards does not mean vertically up, perpendicular. That's, you should note down here, perpendicular to the wings. Right, so when we think about the free body force diagram, first we should draw that, it will be helpful. First part they ask it, explain in terms of forces why the aeroplane is able to fly in a horizontal circle. So we know that when it is moving on a circular path, the vertical component of the weight, the vertical component of the lift will balance the weight. Vertical component of the lift will balance the weight. The horizontal components, so it's going to move on a horizontal circle this way, it's going to move on a horizontal circle this way. The horizontal component of the lift will provide the required centripetal force for the circular motion. So both must be satisfied. The vertical component of the lift should balance the weight, total weight of the aeroplane. Then the horizontal component of the lift towards the center of the circular path will provide the required centripetal force. So the aeroplane will move on a horizontal circle. So I think I don't need to write the answer. I'll tell it again. The vertical component of the lift will balance the total weight of the aeroplane, and at the same time the horizontal component of the lift will provide the required centripetal force for the circular motion. So it will move on a circular path. That's the answer for the first part. Second part, the aeroplane has a mass of this much and flying in a horizontal circle at a speed of 80 meters per second when theta is the angle of inclination of the wings with horizontal line. Okay, better draw a free body force diagram for the second part. So we draw the free body force diagram for the second part. It will be like this. Yeah, we can draw the wings like this. Yeah, I'll draw only the wings because I don't need to think about the aeroplane here. Only the wings I'll consider. Yeah, okay, aeroplane can be like this. So this line makes an angle of with horizontal 30 degrees. So the weight will act vertically downwards and the normal reaction, sorry, the lift will be perpendicular to the wings. So this will be 90 degree. This is the lift. So the weight will act vertically downwards. So weight will act vertically downwards. So this angle is theta. This angle is theta here with horizontal line. This angle theta. So if this angle, so we'll draw the whole thing as simply just like a dot. So this line is there. This is the object. So there's a line this way. This angle theta. The lift is perpendicular this direction. The lift is this direction, which is perpendicular to this line. This is lift. This is 90 degree L. And the weight is acting vertically downwards. Okay, so if this is theta, this will be 90 minus theta. So this is going to be theta. This angle will be theta. Again, this is theta with horizontal, the slope of the wing. That is theta with horizontal. So with the vertical, this is going to be, this angle will be 90 minus theta. This will be 90 minus theta. Because this is theta, this is 90 minus theta. Again, this black color, the slope of the wing and the lift, they are 90 degrees. So 90 minus theta. So the lift will be with vertical line, that will make an angle theta. Okay, so we'll think about moving in horizontal circle. So here I can say it's moving in a horizontal circle means vertical resultant force must be equal to 0. So L cos theta equal to mg. That's the first equation. The centripetal force towards the center is somewhere here. Here is the center. It's going to move on a horizontal circle like this. So centripetal force, that is L sin theta equal mv squared over r. That is the second equation. L sin theta will be the centripetal force. Okay, so divide the second equation by the first equation. L sin theta over L cos theta equal to mv squared over r over mg. That is tan theta equal so m and m will get cancelled, v squared over rg. So we need to find the r. So r is going to be v squared. We know the speed is given 80 meters per second. Yeah, 80 meters per second. So 80 squared over, I made r subject, so tan theta will come down. So g tan theta 9.81 into tan 20, because it make an angle 20 degree with horizontals given. So we'll find the r. So r you will get 1792 meters, almost 1800 meters if you give it in 2SF. Okay, so seventh question, that is related to hammer throwing. So you know, when during hammer throwing, the hammer or the chain attached to the sphere, that will not move on a horizontal circle, or it won't move on a vertical circle. Actually, it's rotated at an instant. It's rotated on a plane which has a slope with vertical. So the diagram shows how it is rotated just before throwing the hammer. So it's not exactly horizontal circle, it's not exactly vertical circle, it's rotated on a slant, on a particular circular motion, like a slant. So here what's happening, the velocity of the sphere is into the board. It's rotated like this, such that at that instant the velocity is into the board. It's moving on a horizontal circle like this. It's moving into the board at this instant. Okay, so first part, draw a free body force diagram for the sphere shown above. So first part, question number 7, first part, free body force diagram. So this is the sphere. Its velocity is into the board. It's moving on a circular path like this into the board. So the tension will act towards the center. Somewhere the center will be somewhere here. It's moving on a horizontal. It's moving on a circle, not horizontal circle, not a vertical circle. So somewhere the center will be somewhere here. So there will be tension this direction. It makes an angle 42 degree with horizontal. So we can say also there will be weight vertically downwards it's acting. So this angle is 42 with horizontal line. This is 42 degree. So this will be 90. So we know this is 48 degree. The angle between the weight and the tension, or weight and the chain, will be 48 because this is right angle triangle. 42. This is 90. So addition of these two should be 90, so that should be 48 degree. So that's the answer for the first part. Second part, if the chain of the, if the tension, I think there's something, okay, so that's a spelling mistake. If the tension of the chain is T and the mass of the sphere is M, then write an expression for the centripetal force at the instant shown above. So it's moving on a horizontal, on a circular path, sorry, not a horizontal circle, it's moving on a circular path, on a slope, it's moving like this, it's moving like this circular path at that instant. Center somewhere here. So the chain, the tension is towards the center, the tension is towards the center, and the velocity at this instant will be into the board. It's rotating like that. So the centripetal force is the resultant force towards the center. That should be towards here, somewhere here. If I say this is the center, so that should be towards the center. That is T plus mg cos 48. That is the centripetal force equation, or the expression for the centripetal force should be this one. Okay, so third part, the calculation. The distance of the sphere to the center of the circle is 1.4 meters. So that's going to be the radius of the circular path at that instant, at this instant. And the sphere completes 2.3 revolutions per second, means 1 second, 2.3 revolutions, means that's going to be the frequency of the circular motion. So A part, third part, A part, calculate the centripetal acceleration of the sphere. Okay, so third part, A part, centripetal acceleration. So we know that centripetal acceleration is given by, anyway, A equal R omega squared, omega equal 2 pi f. So we are going to use omega equal 2 pi f and A equal R omega squared. So A is going to be R, and so omega I can say 2 pi f all things squared. So radius of the circular path is given 1.4 into 2 pi. Frequency is 2.3 revolutions per second. So 2.3 all things squared. This is the acceleration, meter per second square. Solve it. That will be 292. 292.4 meter per second squared. Okay, B part. B part, uh, mass of the hammer is given 7.26 kilograms. Find the tension of the chain at this instant. So we need to find at all questions based at this instant, which makes a 42 degree. The chain makes an angle 42 degree with horizontal. So we wrote the equation for centripetal force, that is T plus mg cos 48. So that we know centripetal force is equal to mass times the centripetal acceleration. So I can say the centripetal force T plus mg cos 48 is the centripetal force, which is equal to ma, mass times centripetal acceleration. Okay, so I need to find the T. So T is going to be equal to ma, mass of the sphere is given, or hammer is given 7.26, into centripetal acceleration 292.4, minus, when I take mg cos 48 to the right side, it will become minus, that is mass is 7.26 into 9.81 cos 48. Solve it, you will get that tension, that will be equal to 2075 Newton. That is the tension of the chain. So this I am using it towards the center of the circular part. Okay, so this is the 8th question. So here a string, a light inextensible string, carries a mass on one end, and it was initially held in horizontal position. So they are saying mass is 600 gram. We can take mg or whatever it is, 600 gram, which was held in horizontal position. It's not slagging. Then it's released. So it's released. So it will move on a vertical circular path. So the first part, derive an expression for the equation for the speed of the sphere when the string makes an angle theta with vertical. So for that, we should know that it's moving under gravity, it's moving under gravity. So it's falling down, so it's losing gravitational potential energy. Initially the kinetic energy is 0, so when it is losing the gravitational potential energy, its kinetic energy will increase. So we use that idea. So it was initially like this. This is the O. It's make an angle theta with vertical. Something like this we can draw. So it's make an angle theta with vertical. Theta. So the vertical height, it has fallen. So the length of the string 1.2 meters. So the vertical height, it has fallen is this much. This is the vertical height. The bob or the sphere has fallen, that is h. We know that h equal 1.2 cos theta. So we know that h is equal to, in this right angle triangle, or we consider this right angle triangle, this is 1.2 meters. So the vertical height h is equal to 1.2 cos theta when it makes an angle theta with vertical. So this also alternative angle theta. So in this right angle triangle, h equal 1.2 cos theta. So there I can write loss in gravitational potential energy equal gain in kinetic energy. So at this moment, you know, always the speed, velocity will be along the tangent. So the speed at that instant, take it be v. The speed is v along the tangent to the circle. Okay, loss in Gp, mgh, h is 1.2 cos theta equal gain in kinetic energy. Final kinetic energy half mv squared. That's the speed we are going to write expression half mv squared. Initially it was at rest. So minus u, because it was released from rest. Here said 0, just released. So make the m will get cancelled. So v squared is going to be cross multiply 1.2 into 2.4 g cos theta. So v is going to be square root of 2.4 g cos theta. So where you can see that when the theta changes, the speed is going to change. So when it goes down, the speed theta will decrease. When theta decreases, cos value will increase, so speed will increase because moving under gravity. Okay, the second part, derive an equation for the tension of the string when it makes an angle theta with vertical. Okay, so the second part, I'll raise this one. Okay, for the second part, we should think about the free body force diagram. So this is the sphere. It has weight vertically downwards. Tension is along the string, this direction. It makes an angle theta with vertical. So this is theta. So this is theta, opposite angle. This is also theta. So this is mg. This is theta. So the center is O. For this vertical circular motion, center O, centripetal force that is given by resultant force towards the center of the circular path. So the resultant force towards the center of the circular path, the center is here. So the resultant force towards the center of the circular path, T minus mg cos theta. So resultant force we need to consider along the string towards O. We need to consider the resultant force towards O. O is the center. So T minus mg cos theta equal mv squared over r. Okay, so T is equal to mv squared over r plus mj cos theta. So we know the m 0.6, v squared over r is 1.2 plus 0.6 into 9.81 cos theta. But v square we can replace by the expression what we got in the first part. We can replace the v with that expression. Okay, so we can continue like earlier we got in the first part v square equal to 2.4 g cos theta. So 0.6 here, that will be 2, 2.4. We can substitute it, so v square, this v square 2.4 g cos theta, 0.6 here 1.2, there will be 2, that 2 divides this by 1.2 g cos theta plus 0.6 into 9.8, 15.886 cos theta. So we can substitute, or we can leave it as this theta expression. G we can substitute 9.81. 0.6 here 1.2, that will be 2, so v square 2.4 g cos theta, that 2 in the denominator will divide this, so 1.2 g cos theta plus 0.6 into 9.8 and 5.886 cos theta. That's the expression for the second part. Okay, so third part, find the speed when theta equal 60 degrees. So we got a general equation for that. So I'll change it to third part. So I'm going to use the same equation. So that's going to be 2.4 into 9.81 cos 60. So v will be equal to, solve it. You can use this equation but we already derived and got it. So v will be equal to 3.43 meter per second. Yeah, that is 2.4 into 9.81 into cos 60. Then you need to take square root of it. Yeah, 3.43 meter per second. Then fourth part, find the tension when theta is 0. Theta is 60 degree, which vertical. So substitute it here. So I'll change it to fourth part. So find the tension. So substitute in this equation. So that is 1.2 into 9.81 cos 60 plus 5.886 cos 60. Solve it. You will get the answer for the tension. Tension will be equal to 8.83 Newton. So those are the answers for the third and fourth part. I use the same diagrams. We can just substitute in the equation what we derived in the first two parts to get the answers for third and fourth part. Okay, so last part, find the acceleration along the direction of velocity when t equals 0. So the fifth part, uh, the string makes an angle 60 degree with vertical, means here it makes an angle 60 degree with vertical. So this is the weight mg is acting along this direction, tension is along this way, this is the center of the circular path. You know velocity will be along the tangent, that means the velocity is perpendicular to the tension. So the velocity will be perpendicular to the tension. So normally we don't mark velocity on a free body force diagram, but I'll draw it here. The velocity is perpendicular to the tension. The question is find the acceleration along the direction of velocity. So, you know there is an acceleration along the direction of velocity every moment during the vertical circular motion. I explained that in my first lesson. That's the reason it accelerates when it moves from higher part to lower part. When it moves from lower part to higher part in vertical circular motion, it decelerates because there will be an acceleration opposite to the direction of velocity. So it will decelerate, right? So here the acceleration along the direction of velocity is only due to the component of the weight along the tangent, because tension is perpendicular to the tangent. So there won't be any component of tension along the tangent. There won't be any component. So we need to find the component of the weight along the tangent. So this is 60 degrees. So this is 60. If we extend this line, so this is opposite angle 60. This is going to be 30 degree. That will be 30 degree because this is 60, which is making vertical. So that means this is 60. This will be 90 degree. This is vertical. So along the tangent, the resultant force is mg cos 30 is equal to ma. Mg cos 30 is going to be ma. So m and m get cancelled. A is going to be g cos 30. That's the acceleration at that instant when the string makes an angle 60 degree with vertical. The acceleration along the tangent will be this one. So 9.81 cos 30. So that will be 8.50 meter per second squared. Okay, so here a small bucket is filled with water and rotated on a vertical circular path of radius 0.8 meter. You know when the bucket goes to the highest point of the vertical circular path, it will become upside down. But the water does not spill out of the bucket. So that means what should be the minimum speed to keep the water inside the bucket. So there the idea here again, the centrifugal effect is the reason for that. Say for example, a bucket is rotated on a vertical circular path like this. This is the circular path. So the bucket is filled with water. So there's water inside the bucket. When we think about the circular motion of the water, it's moving on a circular path. It should have tendency of moving away from the center. Otherwise, the water will fall down or spill out of the bucket. It should have tendency of moving away from the center. So if it has tendency of moving away from the center, what will happen? The water will push the base of the bucket. So according to Newton's third law, the base of the bucket will push the water downwards. There will be a normal reaction, contact force. So that means if there is normal reaction or contact force exists, or if there is a real positive value for contact force, that means the water is inside the bucket without falling out. That's a condition. Here we are going to use. Additional to this, the water will have weight also. The water will have weight that will act vertically downwards. The weight of the water that will act vertically downwards. So these two forces are acting vertically downwards when the bucket is at the highest point, where the bucket will be upside down. Here the R means, again I am telling, the water has the tendency of moving away from the center. due to centrifugal effect. It will push the base of the bucket, so bucket will push it down. That means still water is inside the bucket without falling out. So the centripetal force, this is the center of the circular path, means the centripetal force should be downwards. That will be R plus mg equal to mv squared over r. R is the radius of the circular orbit. V is the speed. Generally I am saying speed at the highest point. Okay. So speed at the high, but we are going to find the minimum speed. The question is about the required minimum speed. Okay, so R plus mg equal mv squared over r. So we'll make the r subject. R equal to mv squared over r minus mg. Now we should know if the water is not spilled out of the bucket, or if the water remains inside the bucket, if the water does not spill out of the bucket, that means there must be a contact force between the water and the base of the bucket. If there is contact force, a positive real value, that means water is still remaining inside the bucket even when the bucket is upside down. So R must be greater than, we put equal sign also, but greater than 0. Use that condition here. So that means if I consider that for the equation 1, we can say mv squared over r minus mg must be greater than or equal to 0. That means mv squared over r should be greater than or equal to mg. M, both sides we can get cancelled because m is a positive quantity, so it won't change the inequality. So when I cancel m, I can do that because both are positive, r is positive. So v squared must be greater than or equal to gr. That means v should be greater than or equal to square root of gr. So I can say, x greater than or equal to 5 means x minimum value of x equal to 5. I can use like this, simply mathematics. So I can say v minimum equal to square root of gr, square root of 9.81 into radius of the circular path is 0.8. So the required minimum speed at the highest point will be equal to 2.80 meter per second. So here also again centrifugal effect is important in this question. Okay, so this is the 10th question. So it's a vertical track of radius 1.2 meters. A small sphere of mass 100 grams is projected from the lowest position of the vertical track at a speed of 5 meter per second. The radius is 1.2 meter for the track. The question is, will it be able to reach the highest point Q along the circular path? Sometimes what happens, it might go up to here before reaching the horizontal position through the O, right? If I think about horizontal line through the O, it might reach, if the speed is not enough, it might reach up here and come down along the track. Or sometimes it might pass the horizontal line, or the diameter passing through O in horizontal direction. Somewhere when it reaches here, it could go on a projectile path. If both are not happening, certainly it will reach the Q. So to reach the Q, the initial speed should be above a particular value. So is it enough? The 5 meter per second, the speed, is it enough to reach the highest point? That's a question. Okay, so for this, first we should find what is the required minimum speed at the highest point. Again, I am going to think about the centrifugal effect. So when I think about the track in vertical track, if it wants to reach the highest point Q, the sphere should be here like this at the highest point. So when I consider the sphere, it will have a reaction force. That means if it follows the circular path or circular track from P, and if it reaches the Q without falling down, at Q, if it still in circular orbit without leaving the track, means it should have a centrifugal effect. It will push the track upward direction due to centrifugal effect. So the track will provide a force downward direction. That's a contact force. So that means there should be a real positive value for the contact force or the normal reaction exerted by the track on the sphere. So the reaction force is R and sphere will have weight downwards. Both will act at the position Q. So the centripetal force F equal R plus mg equal mv squared over r. I just say the speed at the q is v. We will find the required minimum speed at q such that it continues the circular path without falling down at q. So r should be equal to mv squared over r minus mg. That should be greater than or equal to 0, as I explained in the previous question for bucket with water. The same condition here also. So you solve it, so you'll get mv squared over r must be greater than or equal to mg. So m will get cancelled. V should be greater than or equal to square root of gr. So v minimum equal to gr. So that means we can find the minimum speed at the highest point. So that will be 9.81 into r is 1.2. So 9.81 into 1.2, 3.43 meter per second is the required minimum speed at the highest point if it is not falling down. Okay, so it was projected from P. If it is following the circular track and if it has this much of minimum speed at the highest point, I can use the energy equation. When it moves from P to Q, it's losing the kinetic energy. You can say it's 5 meter per second or whatever it is, 5 meter per second. So it should be this much. So it's losing the kinetic energy and gaining gravitational potential energy. So I found the required minimum speed at Q to continue circular motion without falling down, which is 3.43 meter per second. So I can now continue to find the initial speed. What could be the initial speed at P to have this minimum speed at the highest point? To find that, the required minimum speed at P, I'm going to use the energy equation. I'll raise it in one. Okay, right? 3.43 meter per second is the minimum required speed at the highest point. Okay, so now I can continue this question. For the motion from P to Q, I can consider motion from P to Q. I can loss in kinetic energy equal gain in G3A. So loss in kinetic energy half mu squared minus half mv squared equal mgh. All the masses will get cancelled. So u squared is equal to multiply by 2gh plus p squared. P squared is the speed at the highest point at q. When the v becomes minimum, so this is constant because hg can't change because that's the radius and the height, which is 2.4. But when the v becomes minimum, I can find the required initial minimum speed. So u minimum squared equal 2 into 9.81 into h is 2.4 plus minimum. This minimum speed, we found it in the previous earlier, that is 3.43 squared. Okay, so from this I can find the minimum required initial speed. U minimum will be 7.67, which is greater than 5. This is greater than 5 meter per second. So that means the speed at which we are throwing at the lowest point is not enough to reach the highest point, because if it wants to reach the highest point, the minimum speed at P should be 7.67 meter per second. So it will not reach Q. Okay, so this is the 11th question where a battery powered car is moving at constant speed on a vertical circular track. So You know the centripetal force. First part, find the resultant force acting on the car means that is the centripetal force. That will be constant everywhere because it's moving at constant speed. So the resultant force is the unbalanced force, that is the centripetal force, that is going to be mv squared over r. Mass of the car is 25 grams, so 0.025 into v squared, moving at constant speed of 1.8 squared over r, that is radius 0.3. So the centripetal force will be equal to 0.27 Newton. That is the centripetal force. So the next part, sketch a graph of resultant force against time. Okay, here it's moving at constant speed. So the centripetal force is the constant because it's powered by a battery. Normally when you let a marble to throw or sphere throw on a vertical track, the speed will change, as I discussed in the previous question, because they are loss in Gp equal gain in K. But here it's moving at constant speed because it's powered by a battery. So it's moving at constant speed, means centripetal force is constant. So the second part, the graph, if you draw the unbalanced force against time, this is unbalanced force if I say, so it will be a straight line throughout the motion, it will be a constant. So the graph will be a horizontal line. Okay, right. Third part, because centripetal force is not changing, it's moving at constant speed, so centripetal force is constant. By taking upward direction positive, sketch a graph of the resultant vertical force. Okay, so if the question is resultant vertical force, means we need to consider the centripetal force, the unbalanced force in vertical direction. Say for example, if the track is this way, this is the vertical track. So if the car is at this position, so I'll draw the car like a small sphere, easy for that. So the centripetal force should be towards the center. So the centripetal force will be this direction. So I'm not marking the normal reaction. That is the centripetal force. Overall resultant force, centripetal force should be towards the center. If this is theta, the vertical component of the centripetal force will be F cos theta. F cos theta is the vertical component of the centripetal force. Careful. F is the centripetal force here, the unbalanced force or resultant force. So its vertical component FV, upward direction they asked to take it positive, that's going to be F cos theta. So that means when the theta equals 0, at the lowest point it will have the highest or maximum vertical component of centripetal force or resultant force. At the highest point it will have the resultant force, the centripetal force will be vertically downwards. When it is at horizontal position, the car is here, there will be contact force, there will be centripetal force towards the center, but the vertical component, when it is here, the vertical component will be equal to 0. So that's going to be like a cosine graph. So the vertical component of the centripetal force, that will be when the time, the x-axis is time. So initially if I assume the car was at the lowest position, so initially it will have the highest value, that is what we calculated in the first part, the resultant force, that is 0.27. When it reaches the highest point, the same centripetal force, the vertical component will be downwards, which is minus 0.27. When it is at this position, it will have centripetal force. There will be centripetal force, but the vertical component will be 0 because at this position, centripetal force will be horizontal. Horizontal centripetal force won't have any vertical component. We are drawing graph for the vertical component because vertical force, the question says vertical force, resultant vertical force. So at that position, it will be 0. So the time taken to move from here to here is 1/4 of the time period, because time taken for one full orbit is time period. This is 1/4 of the time period. So at 1/4 of the time period, it will be 0. So I can draw the graph like this. If I draw dotted lines here, the graph will be like a cosine graph. So this will be 0, this will be t by 4, this will be t by 2, this will be 3 t by 4, this will be t. Again, after one complete, it will come to that highest position. So this will be the graph for centripetal force or resultant force when we consider vertical component. Students have wrong idea sometimes. They might think the centripetal force is 0. No, we are drawing graph for the vertical component of the resultant force or vertical component of the centripetal force. That will be 0 on either side along the horizontal line, which a line passing through the center, which is a horizontal direction. No vertical component. Okay, so I have discussed 11 questions, circular motion, different type of questions. I hope you understood and enjoyed this lesson. Okay, bye.